Good morning, students. Let us come back to the class. Now we will just recall what are the functions we have already discussed. The identity function f of x is equal to, what is the identity function? F of x is equal to x, and the graph is of the form. It has a slope of 45 degrees with the x and the y axis. Constant function y is equal, f of x is equal to c, where c is a constant. Modulus function x-axis, y-axis, x-axis, y-axis, x-axis, y-axis. Modulus function f of x is equal to modulus of x, and we have seen that from modulus function graph there can be vertical shifting or it can be an horizontal shifting. Parabolic function graph, this is x-axis and y-axis. What is a parabolic function? Standard form is f of x is equal to x squared. It also can have a horizontal shifting or a vertical shifting. Cubic function f of x is equal to x cubed. So these are the standard forms. These are the standard forms of the graph, and it can have horizontal shifting or vertical shifting. So cubic function graph, parabolic function graph, modulus function graph, constant function graph, identity function graph, then linear function f of x is equal to mx plus c. Linear function f of x is equal to mx plus c. And the last one we studied is signum function f of x is equal to minus 1, x less than 0, 0 if x is equal to 0, 1 if x is greater than 0. Now we have also seen what is a domain, what is a range of each and every functions. Now the last one we are going to study is about the greatest integer function. Greatest integer function is also called as a floor function or a step function graph. Greatest integer function graph is also called as a floor function graph or a step function graph. Now, greatest integer function is represented by this form. Greatest integer function is represented in this form. The function rounds off the real number down to the integer less than the number. So that means greatest integer function of x is equal to that value of x which is greater than or equal to x, which is greater than or less than or equal to x. So when you take greatest integer function of 1.15, so it is the greatest integer less than or equal to x. So it is more than one integer, it is equal to 1. Greatest integer less than or equal to x. Now when you take 4.56567, so it will not go up to, it will not be 5, but greatest integer less than or equal to x. Less than or equal to x means it is equal to 4. 50, greatest integer 50, it is equal to 50. Greatest integer minus 3.010, it is equal to the number x less than or the greatest integer less than or equal to x. So greatest integer less than or equal to x minus 3.010. So the integer less than minus 3.010 is equal to minus 4. This is how you define the greatest integer function. And this function is also known as a floor function, or it is also called as a step function. From the word step function, we get an idea like the graph will be like steps. The graph is like steps. Now, I'll read the greatest integer functions are defined piecewise. The greatest integer functions are defined as piecewise. That means it will not be continuous, it will be piecewise. I hope you know all the functions we have defined. I'm just going to rub this side so that we can draw the graph of the greatest integer function. The graph is a piecewise function in the domain of a group of that are divided into intervals in the form -4, 3, -3, 2, -2, 1, -1, 0, and so on. Greatest integer function graph when the intervals in the form n plus 1. The value of greatest integer is n. The value of greatest integer. The value of greatest integer is n, where n is an integer. Where n is an integer. It will be like piecewise. The greatest integer, it will be like piecewise. And suppose if it is of the form 3, 4, the greatest integer function in the interval 3, 4 is equal to 3. The graph is not continuous. Graph is not continuous. Now, let us consider the graph. -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, 4. Zero, -1, -2, -3, -1, -2, -3, 1, 2, 3, 1, 2, 3. -3, -2. So the greatest integer in the interval, closed interval 3, 4 is 3. So -3, -2. So that will be -3 is included. But 2 is not included. -2 is not included. -2, -1. -1, 0. Zero, so -1, 0. minus 1, 0, 0, 1, 1, 2, 2, 3, 3, 4. This is the graph of the greatest integer function. This graph is viewed as a group of steps, and hence the integer function is also called as a step function. The left hand point in every step is blocked by a dark dot. The left hand point, because greatest integer function in this interval is defined as 3. So that point is included. The left hand point in every step is blocked by dark dot to show that the point is a member of the graph. And the other right hand point, open circle, indicates that it is not included in that point. It's not included. It's not included. Included. So this is called as a greatest integer function graph. Once again we will explain what is a greatest integer function. So this is how it is denoted, greatest integer function. It is a greatest integer less than or equal to x. So 1.15, it is more than 1. Greatest integer less than or equal to 1.15 is equal to 1. 4.56567, greatest integer less than or equal to this number. So greatest integer less than or equal to means it is equal to 4. 50, greatest integer 50. So less than or equal to 50, and this is equal to minus 4. And greatest integer function, it will be always a piecewise graph. It is always in piecewise forms when the intervals are in the form of n plus 1. When the intervals are in the form n plus 1, the value of the greatest integer is n. The value of the greatest integer is n, where n is an integer. And the peculiarity of the greatest integer function graph is that the graph is not continuous. Suppose if I take some points, greatest integer minus 3, minus 2, that is n plus 1. Now this is equal to minus 3. Minus 3 is included, but minus 2 is not included. Minus 2, minus 1, greatest integer is equal to minus 2. So up to this interval, it remains the same. Minus 2, minus 1. Minus 1, 0. 0, 1. It is an open. 0, 1. Then 1, 2, 2, 3 and 3, 4. So this is a not continuous graph. It is a stepwise function graph. It is also known as the floor function graph. So these are the different types of graphs in chapter 2, and the functions, the domain, the range, horizontal shifting, vertical shifting, and so on. So with that we conclude that one. Then one more small section is there, algebra of functions. What do you mean by algebra of functions? Let us take the next subheading. Algebra of functions. Let f and g be two real functions. Algebra of functions. Let f and g be two real functions such that f is a function from x to r, g is a function from x to r. Then what will be f plus g x, f plus g, algebra plus, it is a function from x to r defined by f of x plus g of x. So f plus g of x is equal to f of x plus g of x. Similarly, we have f minus g of x is equal to f of x minus g of x. Third one, operation fg into x is equal to f of x into g of x. And the fourth one is f by g of x is equal to f of x by g of x, provided g of x is not equal to 0. This is known as algebra of functions. Now, let us take one example. The function defined is f of x is equal to root x. G of x is equal to x. Defined over the set of, it is defined over the set of non-negative real numbers. Non-negative real numbers. Because root x cannot be negative, x cannot be negative. The question is, find f plus g of x, f minus g of x, fg into x, f by g of x. Algebra of functions. And it is given that the function is defined for non-negative real numbers, because root x is given. Root x is given means x cannot be negative. Now write the definition. F of x, f plus g of x, it is equal to f of x plus g of x, and that is equal to root x plus x. That's it. F minus g of x is equal to, write the formula, f of x minus g of x, and that is equal to root x minus x. Okay, and fg into x is equal to f of x into g of x, which is equal to root x into x. If you want, you can simplify. That is x raised to 1 by 2 into x raised to 1, which is x raised to 3 by 2. F by g of x is equal to f of x by g of x, that is equal to root x by x, x raised to half by x, which is equal to x raised to minus 1 by 2, or 1 by root x, x not equal to 0. X not equal to 0. So this is called as the algebra of functions. Once again, f and g are two real functions. F is a function defined from x to r. G is a function defined from x to r. Then f plus g is a function defined from x to r, such that f plus g of x is equal to f of x plus g of x. F minus g of x is equal to f of x minus g of x. Fg into x is equal to f of x into g of x. F by g of x is equal to f of x by g of x. G of x is not equal to 0. And now you can do exercise 2.3 completely, 2.1, 2.2 and 2.3. 2.1 you have already completed, 2.2 and 2.3 plus 4 questions I have given you as an assignment. You can do it and submit. Plus 2.3 exercise you can do it as an assignment. And next week you will have a test paper on chapter 2. I hope everyone has clearly understood chapter 2 and wish you best luck. Thank you.